All right, everybody. Today we are looking at section 4.8, which is Introduction to Coordinate Proofs. So this is our last kind of proof that we're really going to talk about, and we've kind of done them without actually calling them coordinate proofs. All we're doing is we're using algebra to show geometric relationships. So for example, if we want to try classify a triangle as any of the ones that are here, we can do that using coordinate proofs and using algebra. Same thing with showing triangles are congruent or segments are congruent, lots of different things. So if we take a look here at some of the things that can be used in coordinate proofs, like if I want to prove segments are congruent, or if I want to prove that here, let me kind of slide these over. Some of these are getting off the screen. Okay, or if I want to show that there's a point that bisects a segment, or two lines are perpendicular. Okay, all of these formulas, which you already know and love, are back. Okay, so we've got distance formula, midpoint formula, and slope formula. All of these are coming back in this section, and they're going to help us show different things about different triangles or segments or things like that. So let's kind of go ahead and take a look. I want to prove or disprove that the triangle with the given vertices is an isosceles triangle. So the first thing that I'm going to do is I am going to plot the points that have been given to me. Okay, so I'm going to start by plotting the point 4, 2. 4, 2 is right here. Then negative 1, 1, 2, 3, 4 is here. And then 2, negative 1, 2, 3 is right here. Okay, so this is my triangle. All right, so again, A was at the point 4, 2. B is at the point negative 1, 4. And C is at 2, negative 3. So this is my triangle here. All right. So now I want to use the distance formula to find the length of each side. And notice we've already kind of done AB here for you. So I'm going to find BC. So I'm going to call this one X1, Y1, X2, Y2. And I'm going to do the square root of X2 minus X1. So 2 minus a negative 1. Which is the same thing as saying 2 plus 1, quantity squared, plus negative 3 minus 4, quantity squared. All right, so 2 plus 1 is going to give me 3, squared is 9. Negative 3 minus 4 is going to give me negative 7, squared is 49. And this is going to give me the square root of 58. Okay, then we're going to go ahead and do AC. So I'm just going to take this and I'm going to change this to X1, Y1. All right, so I'm going to do X2 minus X1. So that's going to be the square root of X2, which is 2, minus X1, which is 4, quantity squared, plus Y2 minus Y1. So negative 3 minus 2, quantity squared. All right, so 2 minus 4 is negative 2. Squared is 4. And negative 3 minus 2 is negative 5. Squared is 25. So this is going to give us the square root of 29. Okay, so now the question is this triangle isosceles? So we can say that yes, triangle ABC is isosceles. Okay, because the length of segment AB is equal to the length of segment AC. Okay, so these two have the same length and BC is different. Okay, so we can also say, here, let me take out the period. We can say, and AB does not equal BC. Okay, so AB and AC don't equal BC, but they do equal each other. So we have an isosceles triangle. Guys, that's a coordinate proof. You have used algebra to show something is true. All right, so really this is just using distance and midpoint and slope to get where we want to go. All right, So let's take a look at another one. All right. And again, as we go through these, if you have questions, pause the video, write it down. All right. So let's take a look here. This one is a little bit more of a challenge mainly because we're looking at variables rather than looking at numbers. So we want to we want to prove that in this right triangle, and apparently I didn't attach that to these directions, but I want to prove that M is the same distance from C to B and to A. All of these are the same length. Okay, that is in your notes. Those directions are in your notes, but I just didn't put it on here because I'm silly. All right, so the first thing that we're going to do is we're going to place a triangle in the coordinate plane as such. Now, because we're using a midpoint, remember that in the midpoint formula we divide by 2. So all of my coordinates I want to use as a divide by 2, all right? Or something that is divisible by 2. So that is why these coordinates were chosen to represent the sides and the vertices of the triangle. All right, so let's take a look at how we do this. And I just kind of recopied that triangle over here. I want to find the coordinates of the midpoint because what I'm going to do is I'm going to find the coordinates here, and then I'm going to do the distance formula for MC, MB, and MA. All right, so I'm going to do the distance formula to all 3 pieces to show that it's equidistant. Because remember, that's what equidistant means, is the same distance from each thing. So in order to find the coordinates of M, okay, there's x1, y1, x2, y2. And remember, we add our x's, divide by 2. So 0 plus 2a. And then we add our y's and divide by 2. So 2c plus 0. Okay, so this is really 2a over 2, which when I divide by 2, I get a. And this is 2c over 2, which when I divide by 2, I get c. So hopefully now you can see why we chose multiples of 2 in these coordinates. So that when you divide by 2, you're not dealing with fractions. All right? So I'm going to erase these. Now, I want to find the distance between MA, MB, and MC. So M to A. All right, I'm going to subtract my x's. So I'm going to do 2a minus a. 2a minus a. And then I'm going to do 0 minus c. Okay, it doesn't matter that these are not numbers. It's no big deal. So 2a minus a is a, and a squared is just that, a squared. 0 minus c is negative c, and negative c squared is c squared. All right, so now we're going to do the same thing with MB. All right, I'm going to call this x2, y2, subtract 0, 0. So I'm going to do a minus 0 quantity squared, and c minus 0. So I'm subtracting my y's. So this is a, and then squared, so we get a squared. C minus 0 is c, squared is c squared. All right, then same thing here. I'm going to do a minus 0, and c minus 2c. Okay, so a minus 0 is just a, again squared, we get a squared. C minus 2c, again, is a negative c. Squared is just c squared. Okay, so because MA is equal to MB, which is equal to MC. This, I don't think it's that way on your notes, but this should be a C. It's not like that way on your notes. It's good on your notes. It's just wrong on here. Okay, so we know it's equidistant because all 3 of these, while we don't know what A, B, and C are, we know that these are all the same length. Okay? If you have questions about that, write that down. I know that one's kind of a little complicated because it is using letters. It's not using numbers, but you're still finding the coordinates of the midpoint using that same midpoint formula we've been doing and finding each of these distances, again, using that same distance formula that we've been doing. I warned you guys this wasn't going away, and it's not. All right, next thing. I want to prove that triangle ABC is a right triangle when I'm given the coordinates. All right, so let's take a look. I've got A is at the point, -4, 6. So right on the edge. Oh, hold on. I hit the wrong button here. Okay, so -4, 6 is right here. B is -1, 2, and C is 3, 5 right here. Okay, so this is my triangle A, B, C. Okay, so what I want to do from here is prove that it's a right triangle. So the question is, what are the key parts of a right triangle? Okay, the right triangle should have sides that make a right angle. I want to know, is this a right angle? Because I know these other two aren't. Well, how do I determine whether or not this is a right angle? AB should be perpendicular to CB. So this is the real question, is AB perpendicular to CB? Okay, because if it is, then it's a right triangle. If it's not, then it's not a right triangle. All right, so now the next question is whether or not we remember how to find whether or not sides are perpendicular. Okay, and our key here is that we should be using slope. Remember, the slopes of perpendicular lines are opposite reciprocals. Okay, so remember, we want them to be flip the fraction, change the sign. All right, so let's take a look. I want to find the slope of AB. All right, and I'm going to go ahead and write in the coordinates here. -4, 6. This is -1, 2. And this is 3, 5. Okay. So when I do my slope, remember it is y2 minus y1 over x2 minus x1. Okay, so I'm just going to pick a point, call it y, it doesn't matter. So I'm just going to do 6 minus 2 on top. Those are my y's, and then do -4 minus a -1 on the bottom. Okay, so 6 minus 2 is 4. -4 plus 1 is a -3. Okay, so my slope is a -4/3. So then the slope of CB, again, I'm going to subtract my y's. So I'm just going to do 5 minus 2, and then do 3 minus a -1. Okay, 5 minus 2 is 3. 3 plus 1 is 4. When I look here, I have flipped the fraction and changed the side. So that means that these two are perpendicular. So that means that triangle ABC is a right triangle. Okay, so again, I know it's a right triangle because my slopes are negative reciprocals. All right. And the last one here that we're going to look at is plotting our points here at K, which is -2, 1, L, which is at -2, 3, M is at 1, 3, and P is at 1, 1. All right, so we have here K, L, M, P. All right, and I want to prove that triangle KLM. Well, I don't have triangle KLM, so I need to draw in this diagonal so I have the triangle. Okay, so I want to prove that these two triangles are congruent. All right, so the first step is I know that KM is congruent to KM by reflexive. So I don't have to do that. Okay, the next thing is that I know that this length here is 1, 2, 3. This length here is 1, 2, 3. So I know that LM is congruent to KP. Okay, because I can count. Or you can do distance formula. Now this isn't a great example because the distances are always horizontal and vertical. So this is also 3 and this is also 3. So I know that LK is congruent to MP. But if we were on any kind of an angle, we would need to use distance formula. So if you have questions about that, go ahead and write that down because I know I got my